Um, so if you have read or take a look at the canvas, you should see the online lab files here, and this online lab file includes, I think, 3 files or maybe more. Yeah. So first of all, those of you haven't done lab 6 yet, you're going to use this instruction, and you will simulate lab 6, and you should use the .do file kind of thing that you can use it here, and the due date for lab 6 is by next Friday before the next lab starts, because for lab 6 you don't know how to simulate, so we just extend the time, the deadline for lab 6 enough by week, so you would have enough time to simulate lab 6. So the other things that I need to mention is that uh, for uh, for the submission of this lab, so we had pre-lab, but since we are doing lab online, I mean, we couldn't find a very easy way to check your pre-labs. So the submission for pre-labs would be in this way. So you should submit your pre-lab 1 hour after this lab finishes. So this lab would finish at 3. So the deadline for submitting the pre-lab at is at 4 for this section 9, and the deadline for submitting the project results, which includes a screenshot of your simulation, which we'll see later on, uh, would be due to next week. So you have 1 week to simulate and send me the instruction, and so that will be due to next week before 12. And this is how you will submit your lab. And also you need to submit the answer sheet for your lab, and as the email that Dr. Kamal sent. If you don't have printer, just write your answers on a paper sheet. And I think this is all you need to know about let's say the submission. Yeah. So I was trying to figure out if I can pull up the chat here. So if you have any question, you can just answer. You can just like ask them in the group chat, and just so you know, you can ask question privately, or you can send it to everyone so everyone could see it. Okay, so this is how you should submit your lab, and so we may begin now by reading the instruction. So for simulation, we have this instruction, and in this instruction, as you can see, there are 2 parts. The first part is just like we need to export our design to a VHD file, so that the other application that we are using to simulate the output files from Quartus Prime uh, would be able to simulate those. So we need to export some files from our design. And after that, we are going to go to a software, an application, which is called ModelSim, which you can find it here. You can just like, what is it? So you can go and search for ModelSim, and like this one. Did I have any typo? ModelSim. Yeah, this application, and it should look like this. And this application will do the simulation for us. And So we will figure out how we are going to use this application for simulation. So first thing first, we have to design whatever we want in Quartus Prime, and we have to export it to a VHD file. So the important thing is that we try to export a Verilog code into a VHDL file, but we weren't able to do that. So we strongly recommend to not design your project in Verilog code. I mean, at least for lab7, because you can design it in like a schematic file. So don't use a Verilog code as instruction for lab7 says about designing the full adder. Don't use the Verilog code and use the schematic file for designing the full adder. This is the first point, and the other point is that in lab7 we are going to design a 4-bit adder that has overflow functionality, and so a trick which might be very helpful would be to use the 4-bit adder that is already on in Canvas, which I'm gonna show you in a second. So if we go to modules, and if we go to lab, under lab 6, you should find these 4 files: adder4bit.pdf, adder4bit.bsf, and so on. So I'm gonna go ahead and download these files on desktop, I think. Yeah, I already have that, I think. So this one. So just gonna do the lab7. So if you're just like watching, then you would be able to repeat whatever I'm doing, and you should be fine, I think. And so I have these files now, like right in here. So now I'm going to the U drive. I can do this here. So I'm gonna go to my U drive, and in my U drive, I would just go here to lab7 section 9, and I will copy these files here. Yep. So what I just did is I just paste those 4 files, which just make my life easier for doing lab7. But if you want to, if you want to design these files from scratch, you can do it. I mean, you're more than welcome, but it is the easier way. So easiest way, I think. So let me get back to Quartus Prime. So far, does anybody have any question, or if anything makes sense? So we are going to create a new project here. I'm gonna choose the drive 7 section. Should be that this one. Yeah. Folder 7. So since we are not programming a real FPGA, so it doesn't matter, just click finish. So I'm gonna open these two files. So this is the full adder that has been already designed, so you don't need to do anything about it. So, so let's get back to instruction. This one, this one, and try this one here. Cool. So let's get back to the instruction. So now I have these four, and I will go to modules, and I will go to instruction. This is pretty slow. Okay, so what the instruction says is that we need to go to file. So in here we are using two symbols, and we are going to create a new block diagram file for lab7. So we should create a VHD file for each symbol that we are using. So in order to create a VHD file, you should go to File, create an update, create HDL design file from current file. If you click on it, then you should click on VHD file, VHDL, and then click OK. And if you see here, we're gonna have a .vhd file added to our project for the full adder. So we're gonna create another VHD file for the adder 4-bit. So, but this 4-bit adder that we're using doesn't have the overflow functionality. So if you want to add overflow functionality, you should XOR the last two carry out, right? So just gonna add an XOR here. Maybe a little bit more zoom. And now, very cool. And I will save this one. And now I will create a state of symbol first to make sure everything works fine. Then I will create HDL file. I would click VHDL and then click OK. So now you would see that we have another VHD file added here. And we'll just get rid of these. And I will go and create a new block diagram file here. And from the symbol that we just updated for the 4-bit adder, I'm going to use it to do the lab7. So this is the tricky part. I mean, a very useful tip. So we can just like generate all the pins by clicking on this option. So I just did it once, so like, it's better if you understand that and you saw it. So then this is all the lab7 is about, and not all, but part of it, I think. Right? Yeah. So this is not all the lab7. So because we need to add some XOR gates here for the X and for the Y's input, and which I'm not going to do now because it's going to take time. But we're just doing the instructions so we can see. So the other important point is like if you want to use the .do file, which would really make the simulation process so much easier, you should name the pins just like the way that they're defined in the do file, which we will, I think, post every week in Canvas. So just change the name according to the do file, which I already know what are those, but you have to take a look, and I will just show you in a couple minutes. But the name for the CO is cout in the do file. The name for overflow is overflow. The name for CI is control, and the rest are the same. So after I did this, I would just save lab7.pdf, and then I would create a VHD file out of it. And the good point, I mean, the positive point about simulation is that you don't need to compile, which is very, very good news to me. So now we have 3 VHD files, and we need this .do file. So I'm going to save this one. And so now I have lab7 sim.do, and I'm going to show you the name of the things. So here, so we have x3, x2, x1, x0, and the rest. So I'm going to just like explain that in a sec. How do we implement this in the other page? So this is how do file works, and I'm going to explain that in a sec. So after we have these VHD files, we're done with the Quartus Prime, and we can just like minimize it, and we can start the instruction for ModelSim. So we just basically did the instruction, right? And we are going to ModelSim. Yes. So um, now we are going to do the simulation in ModelSim, which is like pretty straightforward. Just follow the instruction. So the instruction says go to file and change the directory. So I'm going to go to file. I'm going to change the directory and change the directory to the folder that you design your project. And okay, so Alex, your VDI collapsed, but you can stay here. So, I mean, I'm yet recording this session, I think. So I would just like post it on YouTube or somewhere so we can see, and it will. I think it will help others as well. So I'm gonna just like change the directory for the ModelSim to the project that we designed. So I'm gonna go to my U drive. I'm gonna go here. I'm gonna go to this one, and I'm gonna select folder. And after that, it says go to compile and compile. So I'm gonna go to compile and compile 3 dots. I'm gonna see these VHD files. So the other very tricky point, I think, because this is a new software to me, so I thought it is better to respect the order of compiling. So we first use the full adder, and we create the adder 4-bit file, and then we design the lab7 VHD file. So it's better to compile them in order. So I am going to first compile the full adder, and then you're going to see this one here, which asks about do I need to create work library, and you should say yes, and you can just like click on this one so it doesn't ask you next time. So I'm going to say yes, and after full adder, I'm going to compile the adder 4-bit file, and then I'm going to compile the lab7.vht file. And so I compiled every 3 parts, just as instruction says. And I'm going to sit down. So I'm going to have this library window here, which has the work entry. But if you don't see it here, or if you want to find it in another place, you can go to simulate. You can click on start simulation, and you're basically going to see the same window. So if you open, like as it says in the instruction, go to simulate, start simulation under design tab, expand work. So I'm going to expand work, and I'm going to double click on lab7, and I would do the simulation, and that's it all. But the point is that I want to show you how the simulation works. So I'm going to just like try to simulate the full adder first. So after you click, choose full adder, and then you click on OK, then you would see 2 windows appear, object and wave, which in this case it doesn't show up. It didn't show up, so I'm going to use the instruction. It says if you don't see wave, go to view and wave. So I'm gonna go to wave, and I'm now seeing the wave window. So for simulation, you can just simply drag and drop the signals that you want to see in the wave window. So I'm going to drag and drop these here.
What? Shit.
And we can all hear you, Cloudy.
Good.
Yeah. So um, these are the signals that I want to look at. So after I drag and drop those signals to the wave window, I'm gonna right click on signals and force them some value. So I'm gonna force the X to 1. I'm gonna force Y to, let's say, 0. I'm gonna force CI to say 0. And then after I set the input values, I'm just gonna use this icon here as like here it says. I'm gonna use this icon, and if you can't find it, you can just go to simulate, go to run, and run 100. So I can see the output, right? So if you add 1 plus 0 with carry in set to 0, you're gonna see sum to be 1 and C out to be 0. So this is um, this is how you would simulate. But if you want to simulate uh, the lab7 or for the 4-bit adder, we're gonna have uh, many inputs, and it's kind of very hard to set value for each one of them. So, and also drag and drop in the pins that we want to set and see would be a really hard job, right? So we are going to use a do file as it mentioned here. So if you remember that do file that I just copied into the project directory, so in order to run this file, this is the instruction says, just type do the file name, and it's gonna do the simulation so easy. So let's say lab7 sim.do. I just gotta Gifts on Zoom. Oh, geez. So I just figured out that we had a limitation of 40 minutes on Zoom, so it's gonna be, yeah, so it's gonna be a disaster. I don't know what you do. So after I finish the instruction, I think I don't need to share my screen anymore. So we will get back to the regular Zoom, and I hope that the problem will be fixed by the next week. So I'm gonna run this code, and I will see the output. So this is the result that we're expecting you to get, and I just did the lab 7, right? So if you follow the step that I did, I mean, in just like a half an hour, you will be done with the lab 7, and you can submit it. But if you haven't listened, so good luck. I don't know, it's gonna take you a while. So yeah, and for submitting this screenshot, we want you to include the path of your project somehow. So I think for me, um, this is weird. So I mean, for me, I can just like go to File Explorer, so like here, and I can go to my project directory, and I just like put it here, and I will take a screenshot from the whole thing that includes my net ID name, so we can understand that this screenshot is yours. So it's gonna help us with the grading, and so because we are gonna get a lot of screenshots and we don't know whose screenshot is for who, so we basically want you to include your net ID somehow, just like using File Explorer or like I think in Quartus Prime, uh, doesn't work now, but like sometimes it shows your net ID in the file path of the project directory. But anyways, so this is how you should do the lab. And just I want to explain how does the do file works, how this works. So do file first use these commands to uh, like do the same thing that we did with the drag and drop those signals to the wave window. So these commands will just like drag and drop these signals to the wave window, and then it's using these commands to set the input values like 1 0 1 1 0 1 1 1 1 0 1, and then by using this command run, it's going to run the simulation for 100 nanoseconds, I think. So and this 0, which is like a very um, I mean, unnecessary thing to write here. I mean, it is necessary. So, but the point is like you have to write it here, and we don't know exactly what is this is for. But maybe this is just for resetting the input so that you can set it again and for another run or other reasons, which doesn't matter. So, so if we want to set the input values, you can just like use this command and then use run to run the simulation, and then you can set another values for the input, and then you can use run. So the do file is basically a very fast way of simulation, which is not very complicated. So you can write your do file yourself. So this is basically the whole instruction for the at least lab 7 simulation, and for the other lab it's going to be just the same. Um, so this is how you should do the simulation and how you should take the screenshot to submit your lab. And I think this is it. So does anybody have any question? Just put it in the Zoom group chat or just ask now or others.
Yeah, I have a question if you don't mind.
Mhm.
Looking at the output of the simulation, can you explain a little bit more like what I'm looking at? I understand earlier you
Mhm.
had a full adder and you
Mhm.
just like added 0 and 1 to get 1.
Yep.
But with this, I don't really get.
Okay, so with this one, we have x3, x2, x1, and x0, and this is like 1, 0, 1, 0, right? So 1, 0, 1, 0 is 5, true? And then we have x, y3, y2, y1, and y0. They're set to 1, 0, 1, 1. And we have control to set to 0. So it means that we have to add these two numbers. So 1010 is 5, and 1011 is minus, I think 3, I guess, right? Or minus, am I right? It's minus 3, or let me just figure it out. So is 0, it's minus 5, I guess. Yeah. So this is minus 5. So if we add 5 plus minus 5, we're going to get 0. So we have S3, 0, 0, 0, 0, and C out to 1. So that means uh, we added 5 plus minus 5, which is 0. So the result is 0. But if you want to look at it as um, like a not sign number, we are adding 5 to 8 plus 11, which is 16. And this is 0, and we have C out as 1, so it means that it overflows. But if you look at it as a sign number, we have 0, and overflow is 0, so it means that it didn't overflow. So I hope that it makes sense. Does it make
So
sense?
on like the nanosecond thing, is that just the changing of the waveforms? Is that just it doing different tests throughout time?
Yeah, so if you just like right click on it, then you're gonna see that
Oh,
these
okay.
value changes. So it just shows different like setup for the values. Yep. But this is not lab7, so I forgot to add those XORs to the design file, and that's it, I think. So I'm gonna end this meeting because we are gonna go out of time for about quite a few minutes later. Um, and we may want to get back on the regular um, Zoom chat, so Zoom room or whatever it is. So I'm gonna stop recording.